Usually when we think about like math or data analysis, there is this expectation of total unfiltered objectivity.
Right, yeah.
Like a calculator,
Yeah.
You punch in 2 plus 2, you get 4.
Exactly.
You hand a massive data set to a scientist, they run the numbers, and the truth just sort of, I don't know, pops out.
Yeah.
Clean. Undeniable.
We really lean on that comfort, don't we?
Yeah, we do.
Because the idea that data speaks for itself is, well, it's foundational to how we consume news or make policies and just generally understand the world.
But then you step into the actual trenches of empirical science, and suddenly that calculator is completely broken.
Oh, totally shattered.
Right. Or maybe a better way to put it is that the calculator has like 1,000 different buttons that all technically give you a valid answer.
That's a great way to put it.
Because if you give 2 different researchers the exact same data, the exact same question, they might draw completely different borders on the map.
Yeah, they really might.
Which is why today we are diving into a foundational state-of-the-art paper in the world of generative AI that proves just how wild this can get. Welcome to another deep dive, by the way.
Glad to be here.
Today, our mission is exploring a Stanford paper called The Agentic Garden of Forking Paths. And I gotta say, the premise here is genuinely mind-bending.
It really is. It takes a known human flaw and scales it up using artificial intelligence in a way that is, frankly, incredibly illuminating.
So imagine this scenario for a second. What if you gave 2 AI agents the exact same data set, the exact same statistical tools, and the exact same instructions to be rigorous?
Right, no cheating allowed.
Exactly, no cheating. But you just gave them slightly different beliefs to start with?
Just a tiny nudge.
The result is they reach completely opposite, yet scientifically valid conclusions. Okay, let's unpack this. Because, how does it even happen?
Well, to understand why the AI's behavior is so shocking here, we actually have to take a step back and look at human science first. This isn't just a story about algorithms, It's a story about exposing a hidden fragility in all of empirical science.
Fragility like what?
So there is a well-known concept in statistics called the Garden of Forking Paths.
Ah, hence the title of the paper.
Exactly. And it relates to something called researcher degrees of freedom.
Okay, degrees of freedom. What does that mean in practice?
When a human researcher sits down to analyze a really complex data set, they don't just push a single analyze button.
Right.
They face dozens, sometimes hundreds, of defensible minor choices along the way.
So things like what specific variables to measure or what outliers to drop.
Precisely those kinds of things. Like, who do you exclude from the sample?
Yeah.
If someone didn't answer one question on a massive survey, do you throw out their whole profile?
Right. Or do you keep them in for the other answers?
Exactly. What demographic factors do you adjust for? Age, income, education. Every single one of those choices is a fork in the path.
It's kind of like giving 2 people the exact same ingredients and asking them to bake a cake.
Oh, that's a good analogy.
Like one decides to use a higher baking temperature, the other uses a different pan size.
Right, yeah.
Maybe one whips the egg whites and the other doesn't bother.
Exactly. They both technically followed the rules of baking.
Right. They both use the same ingredients.
But the results on the plate are totally different.
And neither of them is inherently wrong, right?
Right. And that's the kicker. The data rarely admits just one unique objective analysis.
Wow.
Human studies have shown this for years in something called the replication crisis. If you give 20 human research teams the same data, they will come back with a really wide dispersion of results.
I've heard of that, yeah. But wait, I'm curious about the methodology here, though.
Sure.
If they are just mimicking what we already know humans do, what makes this AI experiment so groundbreaking?
It's the sheer scale, the speed, and, well, the visibility of the internal process.
Okay, visibility meaning we can see how it happens.
Yeah. The researchers set up an experiment using frontier AI agents, specifically Claude Sonnet 4.6 and Codex.
Oh, okay.
And they tested these agents across 4 high-stakes, real-world domains where human scientists frequently debate the outcomes.
And these are, like, heavy, culturally relevant topics, right?
Oh, very heavy.
We're talking political science, like, does immigration affect support for the welfare state?
Yep.
Public health, does coffee actually affect your health?
Always a debate.
Psychology, does social media ruin teen mental health? And biology, does the gut microbiome affect BMI?
Real, incredibly messy data, the kind of data sets that have, thousands of columns and rows.
Right.
So, for example, they gave the AI agents the data and a really simple persona prompt. For the coffee study, one agent was told, "You are a pro-coffee scientist," and another was told, "You are an anti-coffee scientist."
Okay.
But, and this is a vital constraint of the experiment, both were firmly instructed to analyze it rigorously using your best statistical judgment.
They weren't told to fake anything.
Absolutely not. They were explicitly told to write the code, execute it, and report the findings. There were absolutely no instructions to fabricate data or manipulate the math.
So they basically said, here's your worldview, now go do good, honest science.
Exactly.
Which brings us to the divergent multiverse of results. I mean, what actually happened when these biased agents dug into the data?
It gets wild.
To really understand this, we're going to focus heavily on the immigration study.
Yeah, that's the best example.
Because it's a massive data set that maps directly onto a very famous study involving real human researchers. But before we get into those numbers, I just want to pause here for a quick caveat for this deep dive.
Good idea.
For everyone listening, we are looking at this immigration study purely as a mathematical sandbox to understand data bias.
Right.
We are remaining strictly impartial here. We're not taking left-wing or right-wing sides on immigration or welfare.
Absolutely not.
We aren't endorsing any viewpoints. We are simply reporting the data exactly as the original source material presents it, just to understand the scientific methodology.
The focus is entirely on the machinery of the scientific method itself.
Exactly. So, back to the agents. The researchers ran the pro-immigration AI personas and the anti-immigration AI personas on this massive data set.
Yeah, the International Social Survey Program data set.
Right. And the results. The pro-immigration agents reported that immigration had a positive effect on public welfare support.
Yep.
And the anti-immigration personas reported negative effects. The AI agents reproduced 72% of the ideological gap seen in the real human researchers who had analyzed this exact same data.
They mirrored the human divide almost perfectly.
That is insane.
But here's where it gets really interesting. The methodological soundness of these reports.
Right, because these weren't hallucinated analyses, right? The AI didn't just make up fake numbers to please the prompt.
Not at all. The researchers put the agent's final analytical reports through rigorous independent review to verify the math. First, they ran an independent AI methodological review where 86% of these agent reports passed with flying colors.
Wow, 86%.
Yeah. Then, to be absolutely certain this wasn't just AI grading AI favorably, they put the reports in front of a panel of independent human PhD-level experts.
Oh, wow.
And the humans did a blind review. They didn't know an AI wrote the report, and they didn't know the assigned persona.
Wait. Are you saying human PhDs couldn't tell these were heavily biased AI-generated reports?
78% of the reports passed that human PhD review.
That is mind-blowing.
The human experts looked at the math, the statistical models, the variable choices, and basically concluded, yes, this is a defensible, valid analysis without major methodological errors.
They passed the test.
The agents didn't lie, they just found the quote-unquote correct math to prove their bias.
Here's what I find wild about this. While the agents reproduced about 72% of the human gap in the actual effect estimates, the gap in their statistical significance was, totally off the chart. Yeah. The z-statistics, which measure how strong the evidence is, show that the gap between the opposing AI agents was 9 times larger than the gap between human researchers.
What's fascinating here is that the agents were exceptionally aggressive at navigating that garden of forking paths.
Way more than a human would be.
Exactly. A human might find a path that gently supports their theory. The AI hunted down the path that provided massive, statistically bulletproof evidence for its bias.
Just maximizing it.
Yes, and it did this at warp speed. Each of these full defensible analyses took the AI about 15 minutes and cost roughly $1.68 in compute power.
$1.68 to perfectly engineer a scientifically valid reality?
It's terrifying, honestly.
But if the data is fixed and they aren't faking the numbers, how exactly are they arriving at these opposite ends of the spectrum?
That is the big question.
I mean, are they just cherry-picking the final number? Wait, if the AI is just writing code, how does it know which data points will yield the biased result before it even runs the math? Is it guessing, or is there some kind of feedback loop?
It doesn't guess, it iterates.
Okay.
This is where we get into the causal mechanism of the bias, which breaks down into 2 distinct stages: exploration and selection.
Exploration and selection, got it.
So the researchers didn't just ask for one output. They had the agents run a 10-round experiment.
Oh, wow, 10 rounds.
In each round, the agent had to generate and fit 10 candidate statistical models, run the code, look at the output, and log its rationale.
So they could literally watch the AI's thought process evolve over time based on the feedback it was getting from the data.
Exactly. In stage 1, exploration, you can see the divergence happen in real time.
How so?
Well, in round 1, the pro and anti-agents actually started at almost the exact same place. They ran standard baseline models, and their results were very similar.
That makes sense.
But as they looked at those initial results, they began to tweak their code. If a result didn't strongly support its assigned belief, the agent would swap out demographic controls or change the time frames and rerun the scripts until it found the sweet spot.
And this didn't just happen with immigration either. Like in the public health study about coffee, the pro-coffee agent started hunting down variables that highlighted antioxidants and controlled for sleep loss.
Right.
Meanwhile, the anti-coffee agent zeroed in on heart palpitations and weighted those variables heavier. The mechanism is the same everywhere.
It is, and going back to the immigration data, you can see this clearly in how they measured the core concept.
Yeah.
There were multiple ways to measure immigration in the dataset. The pro-immigration agent started leaning heavily toward using immigration flow data, which is the number of people moving in a given year.
Okay, why?
Because that specific data point mathematically tended to favor positive outcomes for welfare support.
Ah, I see.
The anti-immigration agent, however, gravitated toward migrant stock data, which is the total percentage of foreign-born people in the country.
Because that metric favored negative outcomes.
Exactly.
So that is the exploration phase. They algorithmically sniffed out the specific variables that supported their prompt.
Precisely.
Then comes stage 2, which is selection. Out of all the dozens of models they built over the 10 rounds, the agents had to pick one final report to publish.
Right.
And every time, they preferentially selected the final report from their exploration phase that most closely aligned with their assigned belief.
The logs of how they justified these selections to themselves are genuinely fascinating.
The linguistic tell.
Yes.
There is a detail from the source material here that perfectly illustrates this.
Yeah.
The logs showed both agents looking at a negative, ordinary, least squares linear regression, which is a massive mouthful.
It really is.
What does that actually mean in this context?
Honestly, it's just a standard way to draw a line of best fit through the data points on a graph.
Okay, so a trend line.
Yeah. Both agents saw the exact same downward trend in the numbers.
Right, so the anti-immigration agent looked at that downward trend and wrote in its log that this was proof that immigration reduces welfare support.
Yes. It accepted the math at face value because it fit the narrative.
But the pro-immigration agent looked at the exact same negative numbers and wrote that this was a cross-country confound.
Yep.
What is a confound here?
So a confound is basically a hidden third variable that is messing up your results.
Okay.
For example, if you find that ice cream sales cause sunburns, the confound is the summer heat.
Oh, that makes total sense.
The pro-immigration agent decided the negative math must be flawed because of some hidden variable across different countries, and stated it needed to adjust the variables further to isolate the real truth.
That is wild.
Yeah.
Same data, same downward trend, totally different interpretation.
Yep.
One agent says, this is proof. The other says, this is a statistical illusion we need to correct for. And both reactions are considered standard scientific practice.
That's the scariest part.
Which raises a structural question, I think. If highly capable AI agents and human PhDs can look at the same data and validly prove completely opposite things, how do we trust any single published paper?
It does paint a fairly bleak picture of empirical science, I'll give you that.
Yeah.
But the Stanford researchers didn't just write this paper to point out a massive vulnerability. They used the AI to engineer a solution.
Oh, right.
And to understand it, we have to talk about a major conceptual shift in how we think about scientific proof, moving away from the traditional p-value.
The p-value, you've probably seen in articles, p is less than 0.05.
Exactly.
It's the magic number that gets your paper published in a prestigious journal.
Right, but the p-value essentially assumes you chose the perfect, undisputed way to analyze the data and just asks, could these results be a fluke?
Okay.
To put it simply, it asks, if we keep our analytical choices completely fixed, but we just resample the data from the population over and over, how likely is this result?
But as we just saw with the Garden of Thirking Paths, the way you choose to analyze the data is entirely subjective.
Yes.
There is no perfect, undisputed way.
Which is why this paper introduces a new metric, the m-value, or the multiverse value.
M value.
If we connect this to the bigger picture, the m-value flips the script. Instead of holding the analysis fixed and resampling the data, the M value keeps the data fixed and resamples the analysis path.
Okay, think of the p-value like checking if a specific route on your GPS has traffic.
Oh, good analogy.
It tells you if that one road is clear. The M value is zooming out and checking every possible alternate route on the entire map to see if your chosen route is the only bizarre back road that actually gets you to your destination on time.
That is a phenomenal way to look at it.
Thanks.
The M value is the probability that an analysis path, chosen from all the reasonable, methodologically sound paths available, would produce a claim at least as extreme as the one being reported.
So it measures how fragile your conclusion is.
Exactly. How fragile it is against other valid ways of doing the math.
But practically speaking, human researchers do not have the time, the computing power, or the funding to sit down and run 4,000 different valid analyses on one dataset just to map out every possible conclusion.
No, absolutely not.
It would take a single human team years to do that.
It would be functionally impossible under the current academic grant system. But AI can do it in an afternoon.
Right.
Which leads us to their proposed solution, Agentic Bootstrap.
Agentic Bootstrap. This is where we use the speed and cheapness of the AI not to create a biased report, but to map the whole universe of possibilities.
Exactly.
The researchers unleash the agents on the immigration data without the biased personas and had them run over 4,300 defensible, methodologically sound specifications.
And the total cost for mapping this entire universe of possibilities, about $100.
That's it.
Yeah. For the cost of a nice dinner, they created a massive map or a bell curve of every possible valid conclusion you could draw from that single data set.
And what did that map look like?
It was incredibly wide. The defensible conclusions drawn from the exact same data range all the way from strongly negative to strongly positive.
Wow.
The data could support almost anything if you took the right path.
So what does this all mean? If for $100 we can use AI to map out every mathematically valid conclusion, what happens if we take real published human studies and see where they land on that map?
This is the ultimate stress test of the human scientific record.
Yeah.
Where researchers took the findings of 42 real human research teams who had analyzed this exact same immigration data set in the real world.
Okay.
These were peer-reviewed, published conclusions, and they mapped those human results onto the AI's $100 distribution curve.
And the results of this mapping are stunning.
They really are. They found that 40% of the statistically significant human analyses fell into the most extreme 5% of the AI's analysis space.
Wait, really?
Yeah, that means their M value was less than 0.05.
Let's make sure we really grasp the weight of that. 40% of the human teams who found strong, publishable results were sitting in the absolute fringes of the map.
Yes.
They're what we call specification sensitive.
It means that a huge portion of these highly significant published human findings are essentially drawn from the absolute edges of what is mathematically possible with that data.
But going back to the GPS thing, the humans found the one bizarre back road on the GPS that gave them a spectacular fast arrival time, and they reported it as the absolute standard route everyone should take.
That's exactly it. They aren't necessarily lying, but they are presenting a highly unusual interpretation of the data as if it were the baseline truth.
But why does this happen?
Often it's publication bias. The pressure to publish significant results pushes humans to consciously or subconsciously navigate to the edges of the garden of forking paths.
Because boring results don't get published.
Right. A low p-value doesn't mean much if your m-value is also low. If your result only exists in the top 5% of possible valid analyses, it's not a robust finding, it's fragile.
And that is the true value of Agentic Bootstrap. In an era of absolute information overload, for anyone trying to make sense of the news or scientific journals or health trends, knowledge isn't just about accepting a single statistically significant study that confirms what you already suspect.
Exactly.
It's about recognizing that for complex issues, there is rarely a single point of truth. There is a whole distribution of possible truths.
A multiverse of evidence.
Yeah.
Agentic Bootstrap gives us a tool to finally see that hidden distribution. It allows us to hold studies accountable not just for their math, but for their choices.
Right.
We can finally ask, is this result typical, or is it an extreme edge case? We can ask the AI to show us the whole map, not just the single route the human researcher wanted us to see.
Which leaves us with a final, somewhat provocative thought to mull over. We just spent this deep dive talking about how these agents unconsciously nudged themselves toward their assigned biases.
Yeah.
And how they perfectly mirrored human blind spots. We talked about how cheap it is to use AI to map out the truth and audit the scientific record.
Right.
But, and this is the big question, what happens when humans intentionally collaborate with these AI systems for the wrong reasons?
Oh boy, that is the darker side of the garden.
I mean, imagine a scenario where a researcher, under immense pressure to secure a grant or achieve tenure, uses this massive, cheap generative AI power not to map the truth, but to purposefully construct the most mathematically perfect, undetectable, cherry-picked analysis possible.
Totally plausible.
They could ask the AI to find the one path through the data that guarantees their funding, or wins a political argument, or sells a new pharmaceutical drug.
Yeah.
And because the AI's output passes independent PhD-level review, no one would ever know. As AI makes the garden of forking paths easier to audit, does it also create the ultimate tool for adversarial scientific hacking?
It is a profound vulnerability. I mean, we are entering an era where generating bulletproof empirical evidence for any biased claim costs less than a cup of coffee.
Literally $1.68.
Yeah, the arms race of scientific validation has officially begun. Think about that the next time you see a headline claiming a new study proves something once and for all. Is it a clean math problem, or did someone just find a really creative AI-optimized route on the map?
Always look for the distribution.
Thank you for joining us on this deep dive. Keep questioning the data, keep looking for the distribution, and we will see you next time.